There were two big challenges for AI training, right? The one was data, right? We didn't have data. There's a data limit as to how much you can get data to train. And second was energy. What we saw with DeepSeek, it can use synthetic data. So it's very, very amazing using synthetic data. You can actually solve the data problem. But what we cannot solve is the energy problem. I think that's why it's very, very important if you're doing training to focus on distributing your training runs versus trying to go with the traditional mechanism of centralizing your training runs, because we're going to hit a cap in 2 years and we have no solutions.
I'm past the point of looking for jobs, but I'm not past the point of looking for people to hire. And when I need to do that, I turn to Indeed. Imagine you just realized your business needed to hire someone yesterday. How can you find amazing candidates fast? Easy. Just use Indeed. When it comes to hiring, Indeed is all you need. You can stop struggling to get your job post seen on other job sites because Indeed's sponsored jobs help you stand out and hire fast. With sponsored jobs, your post jumps to the top of the page for your relevant candidates so you can reach the people you want faster. And it makes a huge difference. According to Indeed data, sponsored jobs posted directly on Indeed have 45% more applications than non-sponsored jobs. Plus, with Indeed sponsored jobs, there's no monthly subscriptions, no long-term contracts, and you pay only for results. How fast is Indeed? In the minute I've been talking to you, 23 hires were made on Indeed, according to Indeed data worldwide. There's no need to wait any longer. Speed up your hiring right now with Indeed. And listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed. To get your jobs more visibility, go to Indeed.com/IONAI. IONAI, as always, all run together, EYEONAI. That's Indeed.com/IONAI right now. And support our show by saying you heard about Indeed on this podcast. Indeed.com/IONAI for a $75 sponsored job credit.
Good to see you again, Craig. Great to be here. Thank you so much for having me. My name is Greg Osuri. I'm the CEO and founder for Overclock Labs, the core contributor to Akash Network. Background, being a programmer all my life, being an open source developer for a little over 15 years. And early days of my career helped contribute to this container native ecosystem. A lot of my software I've written is still used by projects like Kubernetes, Docker, and whatnot. And we, big users of the cloud, and we noticed that cloud, as we know, is increasingly becoming more important in our daily lives, considering most of the workloads now are hosted on the cloud. And we felt as it gets more prominent, it also is getting more closed. So we felt the need to have a transparent and open cloud, beginning with how the resources are priced to how the resources are secure, distributed, and whatnot. And in line with what we saw with Kubernetes and what we saw with Docker and Linux, really, we wanted a similar cloud. And that's really our work on Akash began. And it began as an open source project. It still is a very, very mature open source project at this point. But if you go back, the name Akash means in Sanskrit the sky. The sky is where the clouds are formed, so that's where the name came from. And we were inspired by this super cloud concept by Cornell in 2015, where they prophesized that you can actually, if you decouple the resource layer, that means the layer where the resources are acquired, from the control layer, the control plane, you can effectively create a mechanism where anyone can be a resource provider, and that resource provider doesn't necessarily need to be the controller. Right? So that's the concept of supercloud. So really, and we created Akash as this a mechanism to bring the control plane in a decentralized mechanism where No one controls the control plane. It is a community that essentially operates on consensus, and a resource plane where anyone with compute can plug in and offer that to a market at incredible prices today. Akash is perhaps the fastest growing cloud and the most cost efficient cloud. Apples to apples, for compute resources, you have 10 times the cost savings compared to your Amazons of the world. Whereas for accelerator resources, be GPUs, you have nearly 2 to 3 times cost advantage compared to your traditional cloud. So that obviously is contributing to the current incredible growth we're experiencing.
Yeah. So, as I understand it, part of the concept is that there's a lot of unutilized or underutilized compute in the world, data centers scattered around the world that are not being used at full capacity, and those people can make their uh, resources available to anyone in the world, just as Google server farms are available to anyone in the world. And the blockchain layer, the control layer, consists of are they smart contracts then that you enter into with the provider? How does the blockchain layer control the resources that are added to the network by people with excess compute?
Of course. So to understand lay of the land, you essentially have about 7.2 million data centers in the world, right? Um, and if you break them down, there are about 11,000 professional data centers, meaning over 1 megawatt capacity. And the rest of them are smaller data centers, could be closet in a office or whatnot. That is considered data center. So these 11,000 data centers are owned by enterprises. I mean, out of them, about 1,000 of them are hyperscalers. And their utilization rate, I mean, hyperscalers, if you remove them, they tend to have higher utilization because they're businesses. But the 10,000 or so enterprise data centers, their utilization rate is somewhere around 15%, right? So there's enormous underutilization in these 10,000 professional 1 megawatt capacity data centers. And in the not in the professional grade, no, I mean, sorry, the semi-professional grade data centers, we don't exactly know the data that very well. They, some cases they tend to have high utilization, but some cases they don't. But the fact remains there is heavy underutilization, right? Obviously, for AI data center, you have higher utilization. Non-AI, you have lower. And if you're AI, particularly, you have, if you're a professional data center in AI, you tend to have a lot of use when you're training and not necessarily when you're not training, right? And a lot of times if you're training, you need the latest and the greatest chip because the cost advantage is significantly higher if you have better chips. And now the question is what happens to the chips that you made investments to? H100s are now being replaced by H200s. Now, H100s are perfectly great chips. I mean, NVIDIA made about 2 million of them. They're really good chips. But what happens to those chips, right? So once you're done with training. So there's a lot of underutilization and inefficient way of resource distribution in the landscape, right? Now, what Akash does is it takes this compute, essentially, or providers that have this compute can come and offer Akash, and tenants, that means people that use compute, approach Akash with an ask. Essentially, they create an order saying that, hey, look, I am willing to pay $2 an hour for H200s. And this is my configuration. This is what I need. They place their order in an order book, and providers that can fulfill the order bid on the order. So essentially, creating a reverse auction marketplace, right? So the tenant here sets the price. If provider can fulfill, great. If they cannot, tenant obviously doesn't win the bid. So and once a provider bids and the tenant accepts the provider's bid, a lease gets created. This is what we call a kind of a contract, right, between the provider and the tenant, and there's a requirement to make an escrow payment from a tenant. So tenant prepays. That funds are held in an escrow, and those escrow payments are distributed to the provider as provider fulfills the service. So that's how it works. Now, the layer where the tenant creates the order is decentralized. It's open. So all the information besides the private information, I mean, there's no privacy. Private information is collected, but information, when it curtails to the application, is all private. It's not exposed. Whereas um, whereas the resource information, that means the resource requested, the price, that is public. So you have this rich public data, too, is phenomenal if you look at how much people are paying for what, right? And that rich data is used to price the resources by providers, whatnot. So once the provider and tenant gets into an agreement, the blockchain goes away and the relation becomes peer-to-peer. So I am talking to provider directly. There is no intervention. There's nobody in the middle, right? Blockchain comes into place to enforce a contract and enforce payments, right, in a decentralized manner. So enforce payments in the sense, if the escrow account is out of money, the workload gets undeployed, essentially. Right? That enforcement happens from the control layer. If the provider doesn't fulfill the order, the lease gets canceled, the money goes back to tenant. That layer is enforced. Every time somebody needs to pay for the resources, that layer is enforced on the blockchain. But blockchain is just a coordination mechanism that enforces control, but not an execution mechanism, because blockchain is traditionally not a good.
That's right, but the enforcement doesn't happen on the chain either, does it?
Well, enforcement is really pulling the resources back. I mean, pulling money back, right? If the provider falls, the provider doesn't get paid. If tenant falls, the tenant, the money goes to the provider. So that's sort of like mediation happens on the blockchain. Well, ultimately, it's the providers. I mean, that will comply as long as they agree with the protocol.
Yeah, but when you said once a match is made, then it's peer to peer. That's off outside of the blockchain, right?
So what happens between the provider and the tenant? It's up to the provider and the tenant, right? Now, provider can choose to give the tenant more resources if they want to, but the question is, why would they?
No, that's right. Just on the enforcement, I don't quite understand if you have compute resources, I have a workload. I find you through the Akash network or through the blockchain, or then you and I'm sending you my workload off chain and privately peer to peer, and something. How does the chain know whether or not something's gone wrong? I go back on the chain and report it, or what? How does that happen?
Yeah, the first obvious thing is you didn't get the resources that you need. So there's a verification mechanism that chain enforces on the provider. So there's checking, there's all kinds of things that, hey, did you get the resources you said you're going to need? If the provider did not, well, the contract yanks, you get your money back. So it's obviously, once you get the resources, you don't usually have a problem, and then you have problems later, yada yada yada. If your workload gets dropped by the provider, it gets yanked, you get the money back, right? So there are certain aspects of like, and quote unquote enforcement, because I use this word loosely because no one can control you. That's the whole point here. But if you do not comply to the contractual obligations, your contract gets yanked. Now, is there indemnity in the sense like, well, what happens if some nefarious activity happens? Yes, there's absolutely indemnity in certain category providers that are audited, right? So not all providers are. You can be anonymous by default as a provider, but people are reluctant to deploy on someone without knowing who they're deploying to. I mean, it could be anyone. So there is a degree of identity that's exposed from a provider standpoint to the tenant in case you need indemnity, right? There's also something called TEE, or Trusted Execution Environment, where if you need to run your entire workload in a fully private mechanism, fully encrypted mechanism, all the way from the chip level, even chip to chip, communications to be encrypted, you can use TEE, which is Trusted Execution Environments. Now, with TEE, of course, the challenge is there's a little overhead in terms of in terms of performance because of encryption, but it gives you security guarantees. If your application requires that level of security guarantees, you can take advantage of the TEE so that nefarious activity wouldn't occur.
You were talking earlier about the data centers around the world that are independent, right? That are not part of the hyperscalers. Uh, how does that? Can you give? Do the hyperscalers account for 80% of compute, and these independent data centers account for 20% compute in the world, or is it the other way around? Or yeah, can you give us a sense of scale of not what's on the Akash network today, but what your sort of addressable market is? I mean, how that compares to the Googles and AWSs and Azures of the world.
Yeah, so we measure. Compute is a there's no direct way to measure compute because it's very there are too many dimensions to measure. But if you take down like the amount of energy being used, you can get a fairly good idea. So there are about 1,030 megawatt data centers. Okay, I mean half of which are located in the US, but so 30 times 1,000 is 30,000. That's it, 30,000 megawatts, right? And there are about 10,000 1 megawatt plus data centers, right? So 1 megawatt, between 1 megawatt and 30,000 megawatts. So about 10,000 there. So if you from a high like 1 megawatt above, situation, I think about 60%, if I remember correctly, 60% are hyperscalers, 40% are non-hyperscalers. And I think that number is growing. Hyperscalers are growing. Hyperscalers are limited by two main things. One is energy, and second is water, fresh water. So you need to have good energy and clean water in order to build a hyperscale data center, and that takes a very long time to acquire. In the United States, we have our entire grid capacity is around 1.2 terawatts, right? So 1,200 gigawatt capacity. And we are not good at, building more energy because of regulation, and it's quite a lot. If you look at the interconnect requests, that means the connect requests that want to connect to the grid, the new supply, there are about 1.9 gigawatt capacity that'll come on board in the next 14 years. But if you look at the timing, they're very, very, very slow to connect to the grid. There are all kinds of problems why that is. I mean, all the way from aging grid infrastructure to regulation to, if you want the most efficient, power, which is a nuclear reactor that can produce up to a gigawatt. I mean, 800 megawatts, 1.2 gigawatt capacity, like the old school reactors. The last one we built took about 14 years in the US and about $32 billion, right? So it's very, very expensive to build. And also, with the new regulations, the Gen 3 reactors, the cost per kilowatt hour is about 15 cents, I believe, 10 to 15 cents a kilowatt hour, which is prohibitively more expensive than natural gas, right? So there are a lot of, it's very, very complex and very challenging environment to bring more data centers. So there's a big question like how can hyperscalers survive, sustain building more data centers. In fact, if you look back, NVIDIA tried to build a hyperscale data center, and NVIDIA owns all the chips. Like the question you may ask is like, why wouldn't NVIDIA go just build a data center? They couldn't get more than 20 megawatt capacity. I know this for sure because I know the guy who tried to build it in NVIDIA. So it's very, very hard to get capacity. And the last nuclear reactor we had was the 3 mile island in Pennsylvania that was swooped up by Microsoft, right? So supposedly, the Stargate project is supposed to bring more nuclear, but let's see what that happens. So your better bet, I think, is can we actually build non-hyperscale, like sub 10 megawatt? Sub 10 megawatt, you can get away with over highly dense solar powers, wind. You can do renewables for 10 megawatts, and that tends to be a bigger trend now. So I'm extremely skeptical if we are able to move as fast as we want in the hyperscaler market, but I think we have a bigger chance to move in the second tier market, which is the 1 megawatt to 10 megawatt. And I think we have an enormous opportunity now to move in the 100 kilowatt to 1 megawatt capacity data centers too. These are small modular data centers. These can be fit in a container, right? Microsoft is experimenting with them. All kinds of innovative things you can do in terms of cooling, in terms of like placement and whatnot. And the advantage you get with a smaller 100 kilowatt or to 1 megawatt data centers is tapping into distributed grid. There's solar energy everywhere, right? So we actually wrote a paper. I mean, Akash, happy to share that with you. I mean, we did this analysis on like, okay, if AI is going to be so important in our lives, if I want everything in my house to be an agent driven, so this conversation right here should be, recorded by an agent, should be processed, insights. I have a year-old at home. I want to know everything she's doing at home while I'm working. Hopefully have an agent that'll warn me if she's getting into things she shouldn't be getting into. I want the whole house to be automated, every conversation to be recorded, but I would hate that conversation to be stored in a cloud because I do not trust anything that leaves my home network as no one should. Okay, now can I have a sovereign AI in the home? I think most people would want an AI in the home as long as it guarantees privacy, right? And I'm building that. But okay, what do I need to get the latest and the greatest AI in the home? Well, DeepSeek, 365B, can run very well on H200 clusters. It needs about 8 H200 clusters. And that costs about $500,000, that cluster, right? Now, we did some study. We said, feasibility study, like, okay, is there any way you can have sovereign AI in a semi-professional data center that takes about 30 kilowatts of energy in the home with that is cost efficient? And the answer was yes, absolutely. If we can acquire about 5 of these H200 8 by 8 chip clusters, these are called HGX clusters, essentially, about 40 chips, over earning about, first year about $2.3 dollars per hour, 80% utilization with 20% overhead for cooling. Your capex slash opex plus opex can be recovered within 5 years by placing them on Akash. What you're doing is you're literally allocating one HGX cluster. HGX has 8 chips to your home use. So that's completely dedicated, 100% utilized to your home use. The rest 4 of the HGX clusters you're offering on the market for 80% utilization. Since you already have the cooling and energy infrastructure, now we can further reduce the cost by having solar panels. Now, the big challenge with solar is obviously storage, right? So solar only comes for 8 hours a day or max 6 hours if you're lucky, actually. But storing, like, say you have 100 kilowatt capacity or 30 kilowatt capacity, storing that much capacity for over 10 hours requires a 300 kilowatt battery, which is prohibitively expensive. It'll cost you about $200,000, right? So, but if we can sell it back to the grid, like, okay, overproduce the energy, use the energy to sell it back to the grid. In Austin, you get about 4 cents a kilowatt hour, 3 to 4 cents, depending on your region. That way, you can pay for the compute, by tapping back into the grid, right? So grid will sell you back at 10 cents. I know it's a scam, but grid will sell you at 10 cents, you sell at 4 cents. Still prohibitively, not prohibitively, very, very feasible. So we did all this study. That's why tapping in to a home network, a semi-professional home network, um, and this will take 142U rack, which is can put in closet. When AI becomes very important, if AI has to really enter the home, which I think it will, I think that's when we're going to see an explosion of these data centers. It could be an office. It could be anyone that want to get a rig. It could be someone, university, for example, they want to get a rig. As long as you have solar, you can completely actually, very efficiently run. So there are about 7.2 million of these data centers. We had about 8.6 million, peaked in 2017. Obviously, cloud came and like killed a lot of these data centers, but I think there's going to be a resurgence of these data centers for privacy, for ownership, for cost reasons, and that's one of our goals is to have a decentralized AI, and we're going to achieve that by decentralizing the energy production and energy consumption as well.
Right. But for the time being, they're not in the home. Primarily, they're small data centers scattered around the world. As they sign up, if I have a workload, do you have an orchestration layer that routes my workload to the right data center, or do I have to do that on my end?
Yeah, so it wouldn't do the data center selection for you by design, because the blockchain is not application aware for privacy reasons. Remember, a blockchain is a public chain, and in order for it to route, it has to be very application specific because every application has a different way of scaling. Um, and but so it has a bidding engine, doesn't have a matching engine by default, and application specific information is one reason. Also, a lot of times you get back a bid with better resources that you may need, better price performance that you may need, because a lot of times people don't actually know what they need. That's why you go to a store and be like, oh, I thought I need this, but I need something else. So a lot of times, people can, sometimes you can compromise too. I mean, you don't exactly get what you want, but there is something that's equally good. You should be able to purchase that, right? Like, so that's why it's very, very hard to develop a matching engine for humans. And so Akash doesn't have automatic routing. Now you can lease out multiple data centers on Akash and have your own routing mechanism, bring your own router, we call it. But that again is very application specific because you understand the application way better than the infrastructure provider. Akash gives you the sovereignty and control for you to be able to have flexibility to route your application everywhere. So yeah.
So you put a bid on the chain. Is that right? The bid goes on the chain. It's seen by all the providers attached to the network. They bid on it, or I'm sorry, you put a RFP or whatever on the chain. They bid on it, and then you select whichever one you want, or you can split your workload between multiple providers, I would guess. What happens if I mean, well, two questions. First, in the beginning, you're going to get a pretty reasonable number of bids. But as this network grows, the day could come when you get more bids than you can reasonably go through. Is there going to be an application outside of the chain that can sort through these, or is that something that you guys are going to offer so that people can find the optimal partner or compute provider?
Yes, bid selectors, we call them. It is on the roadmap. So you can select a bid selection strategy, that's optimal for you. And these are pre-created strategies optionally, right? So it can be like, hey, cost first, optimal for cost, latency first, optimal for latency, or combination of cost and latency, cost first and latency later. You can have all kinds of rules, a rules engine based sort of like, in fact, we're looking a little beyond rules engine. We're looking at an agent based mechanism where agent can adapt to different situations. Considering agent knows your application, you can read your code, understand your code, how it works, and make the appropriate choice for you instead of a rules based system where it could be fragile. Um, yeah, so yeah, we definitely have, and we in fact we have applications built on top of Akash, different providers like Prime Intellect, uh, NVIDIA actually uses Akash. They have their own product called Brev. There's a product called Venice. They're all different products that actually have their own selection engines because they auto scale. So the idea of Akash was it gives you primitives. It gives you, it's like Lego blocks, right? It gives you all these cool things, and as a programmer, you can decide what to do with those Lego blocks, right? So more often than not, people don't. There are a lot of people use Akash directly, but most of our usage comes through the distributors, meaning NVIDIA's, Prime Intellects, and Venice of the world, where they offer, and Bitmine, a whole lot of things out there. They offer their own flavor of Akash on what they think, is the best winning strategy for the bids, right? Absolutely. I mean, there should be a bid selection engine. Will Akash provide it? Probably will give you options that'll make your job easier. Um, Assuming that you're a power user and you understand how these bids work, but we want to be as explicit as possible in terms of granularity that you have full control over who you get. And I think that is a very important capability.
And you mentioned price and latency. When the bids come in, do they come with some metric that measures latency for your where you are, where your workload is?
They give you the region where the workload will be placed, everything you would need to make the selection, right? And so you can write a latency checker. Essentially, they'll check the latency depending on where your users are. So typically, what you would need is you would analyze your user traffic and you would select a mechanism where it'll select the data center that's in 95th percentile of your user activity can be achieved within 50 milliseconds of network latency, right? So that's really what you want to do. But those controls need to be written and that need to be specified based on your application. Some application latency is a very complex thing because, like, if you have hyperscale applications like Facebook, you most definitely have different shards on different regions, right? So California users come to California, New York users come to New York, and more importantly, the data should be available in these local regions, right? And what happens when you have a New York user trying to access California, or when they travel, a New York user goes to California? So this little, it's latency-based selection is not as easy one would think. It's easy when your application is simple, but as it gets more complex, it gets very, very, very challenging, right? Like, so yeah, so you can't just have a latency engine because you may not actually give the right information based on the application.
Yeah, and then the other thing you mentioned that you may not want to put certain information with a hyperscaler because you're concerned about privacy. How do you know how secure these compute resources are on the Akash chain? I mean, how you may be accessing a small data center in Hong Kong. You're not there. You don't have people looking at their security protocols. How do you ensure that you're secure?
So there are two main mechanisms Akash provides. One is a decentralized auditor mechanism, where if the provider says, "Hey, they're compliant, they're HIPAA compliant, they are, whatever standard compliance they have their tier 4 data center, they are, the tier 4 in terms of redundancy and whatnot." These auditors go and verify that off chain. They literally run applications, they run audit checks, the physical proof, the paper proof, they actually go verify, and they post their results on chain saying that, "Hey, I have verified that this provider says who they are, their identity, more importantly, because if something goes wrong, you want to go after them, kind of thing, right? All the information is posted on chain. I mean, in fact, not the verified information by multiple auditors, right? So as a tenant, you can choose the auditors you want to select, and these auditors are public figures. Like Overclock Labs, Mr. Akash is one of the auditors, for example, right? Second mechanism is we provide something called TEE, or Trusted Execution Environment. What TEE does is it gives you a non-custodial way to encrypt runtime, not just transport. So your transport is obviously encrypted, right? That means communication between you and the provider is encrypted. But what's not encrypted is what's in the memory, because it's hard to encrypt. Well, so anyone with physical access to the machine can theoretically, like, if they're talented enough, can theoretically look inside what's in the machine, what's running. To avoid that, you want to encrypt the memory itself, and that's achieved through trusted execution environment. Now, the trade-off, obviously, there is you need more resources because it's encryption, right? It needs more compute, it needs more GPUs. So if you're doing AI, NVIDIA has this amazing TEE mechanism in the newer chips, H200s and H400s, where they encrypt memory within the chip itself, and they also encrypt the transport between the chips using NVLink. NVLink is 3.2 TBps, which is very, very fast, terabyte per second. So it may slow down a little bit. We see right now, we're seeing about 10% overhead, which is not bad trade-off if you want privacy, right? Especially if you're unknown data center. But if you're deploying on something called like Equinix, which is in US, which is a professional grade data center, you don't have that problem. So you're more relaxed when it comes to like, hey, okay, we can trust this data center or whatnot. But ultimately, yeah, you have to trust somehow, right? Um, so either through encryption trusting or through auditability trusting. But this way, you actually have a lot more, uh, tools at your disposal that you normally don't get when you go to a data center directly and with them, right? So you have all these like infrastructure that Akash gives you that you don't normally get going directly. So going to hyperscalers, you just trust the brand. You say, okay, Amazon will not do something. You're trusting that Amazon would not do something. I mean, there's a good amount of truth to it, but we know how this trust could be corrupted. We just don't know what's happening. If you're a big company trying to use Amazon, they'll let you open the boxes. They'll literally show you. Like if you're having 100 million, if you're Department of Defense, they literally let you audit everything, right? But if you're a Joe Schmo, no one cares. They just no, you wouldn't even know if someone has access to your data. It's very famous with ChatGPT because one of the engineers under interview, they said, yeah, we look at users' prompts. So I felt violated because, like, okay, my prompts are good lord, right? All kinds of things. And I'll be judged by the person that is looking at my prompts, and that feels, violation of privacy, right? And if you have anything on the cloud, there's no guarantee that these people are going to look at your thing. But if they adhere to certain standards and they don't comply, and you have some degree of like, indemnification, right? So that's why I feel like if you want ultimate privacy, you have to run in the home. There's really no way. Second best thing is TEE. If you can't run in the home, well, little overhead. Right? And third best thing is probably like just ultimate trust in the provider. But Akash gives you that TEE, which is much better than a cloud provider.
Yeah. And then the other question is, if I'm running a workload and my data center goes down, or maybe there's an outage, and the backup doesn't happen, the generators don't kick in or whatever, what happens to my workload?
It dies. And so you have to know how to be redundant for your application. And that's one of the big areas. You had the same problem with the cloud today, too. And cloud work, Amazon has about 200 outages last year, right? And we all saw what happened with CrowdStrike. Somebody could push bad code, and the entire US airline infrastructure came to a standstill because people couldn't fly. So, centralized systems generally have a lot of faults that they don't expose. But so one of the key design patterns to use Akash effectively is to be redundant from the get-go. Akash makes it cheaper and makes it more optimal to be redundant, but there's really no silver bullet. and this happens all the time, right? So we see ISP, like that's why you want to see when someone says they're a tier 3 or tier 4 data center, that means they have a dual ISP, ideally with a Starlink backup. And we happy to share you the AEP we wrote recently. Like, okay, how do you design a home data center with dual ISPs with a Starlink backup? Where dual generators, you need a diesel generator with automatic switch off, as well as a gas generator, and ideally solar panels. So we have all and USPs. I mean, the uninterrupted power supply, UPSs, and whatnot. So so all these aspects are verified. So it reduces the chance of faults, but faults happen. You cannot prevent faults, but what you can do is come back up faster, right? So no matter, like Mike Tyson says, no matter how planned you are, your plans are only as good as you get punched in the face, right? So you will get punched in the face when you're running infrastructure, and that's the reality of infrastructure. And you talk to anybody that tells you infrastructure, runs infrastructure, will tell you there will be faults, no matter how hard you think you build your data center is. But it ultimately comes down to redundancy. You can run in a quorum, for example. Like if you have a database, well, don't run a single database. Run, a master slave. Sorry, you're not supposed to use the words, like a leader follower style database, where if your follower goes down, the leader will self elect a different leader, or spin up a new follower database that'll always be alive, right? So you need to be a little bit more professional to use Akash now natively. Now there are applications on top of Akash that makes all these things easy. You don't have to think about redundancy. Like you just click a button, it's taken care for you, right? But that's very application specific. Akash doesn't provide by design those redundancy mechanisms because, again, it depends on the application, right? How you, like a lot of times when you're scaling databases, you need to think about consistency. What level of consistency you want? If you want immediate consistency, so when you have multiple nodes in a database, right? Um, uh, and you want to make sure all the nodes are presented giving the same data. Well, if you have multiple nodes, if you want to be redundant, you have to have them in different locations around the world. Well, they're not going to present the same information because there's latency. There's east to west, 300 millisecond latency, right? So if you want an immediate, consistent database, you got to make sure all the data sets are replicated. It takes about 300 milliseconds. So when you write, you can't read immediately. You got to wait 300 milliseconds. That's called immediate consistency. Well, if you don't care about immediate consistency, eventual consistency is fine with you. That means you write a data entry in California. That entry takes about, you're assuming the reader is reading back from California and not reading from New York, and you're fine with that. So if you're building social media, you're fine with that. But if you're building something like a banking application where someone withdraws cash from an ATM in California, should not be able to withdraw within 300 milliseconds in New York. You need immediate consistency. That's why scaling and redundancy planning is very application specific. And so that's why Akash doesn't make the choice for you, and you have to design your redundancy on how you want to see it.
So this is new, right? I mean, how long has the network been operating?
About 4 years now. 4 years.
4 years. Yeah, and as you said, the demand for compute is presumably going to rise sharply as AI spreads through the economy. Do you have a target for how much compute you'll have on the network by X date, or any sort of roadmap that way?
Yeah, so we're growing at 10x now every year, which has been phenomenal. We hope to continue to grow 10x. So right now we have about, we want to get to about 10,000 GPUs by end of the year, which we think we can. Now about 100,000 GPUs by end of next year, about 1 million GPUs within the next 3 years. And we're doing fairly well. We're doing really well. We're growing really, really well. We're growing at 20% thing month over month now. And more importantly, it's not how much compute you want to get. For us, it's about how much compute we have on the network gets used. So utilization rate is extremely important. So we scale responsibly because every time there's a new compute, a new provider that comes to Akash, they should be able to sell out their inventory, right? If they're not selling inventory, there's no point in coming to Akash. So very, very important for us to make sure there is a good equilibrium between the provider's capability to sell compute and the tenant's capability to scale their workloads, right? Again, if provider sells everything, I mean, there's no inventory, tenants will be upset. So that's why you got to be very, very careful in how you scale the systems. Our utilization rate right now is 70%, very healthy, very, very good. Now, that utilization rate can go up as we scale because there'll be more resources generally in the pool. But so our constraint is utilization rate, and we don't scale without that. So we're doing very, very well now. And I think our next big goal is transitioning from a resource market to a services market, a resource economy to a service economy. So right now, think of Akash as just a marketplace for resources, like coming to a commodities exchange where you can trade gold and whatnot. But it is not a marketplace for services. So a lot of times when you're building AI systems or any systems, as a matter of fact, you use several resources like databases, vector databases, to inference services, to agent, hosting platforms, to a whole lot of services that one would orchestrate together to build. And a lot of times when you look at the cloud providers, the resources are open source systems. Look at Redis, for example. Elastic Cache on Amazon is Redis. Or the SQL, the database services Amazon offers is MySQL or Postgres. These are open source protocols, and Amazon really takes them and white labels them and sells them. We feel like if we empower open source developers to be able to provide their services on Akash, we can effectively have a sustainable open source ecosystem. Right now, a big challenge for open source software is sustainability. Docker, for example, Docker is one of the most widely used, open source container infrastructure system, but they couldn't figure out a business model after raising it $1 billion valuation. They sold to peanuts to Nutanix. They're no longer an open source company. Kubernetes, one of the 80% of the globe uses Kubernetes. They can't keep their contributors together anymore, right? Look at besides Linux, which has a very weird founder and it's a very special founder. Besides Linux, we don't have any example in the wild that remain purely open source, right? And successfully. And so we have to change that. We have to create an economy for open source contributors to be able to sustain themselves to build open source software. And I think that is what Akash is going to transition to, the services economy. And that's coming next year. I think with that, and also we also measure revenue per GPU, right? So revenue per GPU is right now at $20 per GPU per day, which is fairly good. We were $10 a year ago, and we did a good job in increasing the revenue per GPU. But with additional services, we can further improve our revenue per GPU to about $50 to $100. Right, that comes with premium services on top of it, and that revenue goes to open source developers, right? So we not only look for like just capacity per se, pure capacity, but we also look at how do we increase our value per resource that we provide, as well as how do we scale while maintaining good utilization. That's very, very important for the health of the network. The more healthier the network is, the higher chances of success we have in the future. So yeah.
Well, so how does someone? Once you have the services up, presumably you'll have people that can onboard a tenant, as you call it, or a user, and walk them through the system and get them connected and do all of that stuff. But for now, how does somebody use the network?
So you could go to Akash Network, and there's a button that says deploy. There's an application called Console. Console at Akash Network is a great way to get started. There's $10 like free trial if you want to go try it. It's actually very good to use. Highly encourage folks to try it. No signups is very, very straightforward. People love it. Uh, if you want a more easier system um, in terms of like getting like SSH style like access, you can go to Prime Intellect. They use Akash underneath. Deploy a resource, you'll see the power. Um, so there are several ways, but I think the best way is to go directly because you get the most cost advantage. Right now, I don't know if you have any H100, H200s left on the network because they go like hotcakes, but H200s are $1.99 an hour, which is the lowest compared to Amazon. I believe Amazon is $4 or $6 per hour, but like 3 times cheaper. Um, and the reason why it's cheaper is because I'll send you the link where we did the cost analysis, right? You can actually amortize your investment while with you know with the decent utilization rate fairly easily. So there's no reason why you should be paying Amazon margins. I mean, Amazon makes record level margins from you, right? So you remove all the margins, the resources are actually fairly cheap. That's really what Akash provides. So that's why resources are very, very cheap on Akash. But they go out like H200s are gone. I would have been like, our utilization rate was like 98% last we saw for H200s. That's a problem with like hot chips you don't really have availability, and we're trying to improve that as much as possible. But A100s are available for, H100s are available for $1.20, which is also very, very competitive compared to Amazon. So highly encourage folks to check it out. If you want to see the pricing, you can go to Akash Network/GPUs and you'll see the GPU pricing, and you'll find them extremely competitive. You also get to know how much availability there is on the network, so you can plan. I highly warn you, it's very addictive, especially when you automate. So a lot of our users just automate the hell out of it because the moment they see a GPU, gets swept away, especially with H200s. DeepSeek runs really well on H200s. So it's very addictive because people are like constantly bidding, you get into this like really cool game. I think there's also somebody that's building futures where they actually purchase the compute and they resell the compute at a higher rate. So it's a very fascinating market actually.
Lastly, you're not the only decentralized cloud computing platform out there. How do you regard yourself in among the competition?
So we're definitely the leaders. We're the first one, and we're the leaders. So there are a lot of copycats. I mean, success gets copycats, and that's a reality, right? We are not the only one, but we are the first and the biggest open source cloud. So the new copycats are actually closed source. They take our code and fork our code. We've seen that several times, right? Um, Now, not to disregard the competition, but I think it's a good thing that people are looking at our model and seeing the success behind a model and trying to have their own flavor. And they obviously want to stay closed source because, well, it's advantageous to be closed source because you can ship code faster. So Akash is very decentralized. I think from a pricing standpoint, we're much better. From a pricing, we have much better SDKs. We have much better user experience. We have much better uh, in several aspects, and also you have a lot of we have about 30,000 developers in our discords. Anytime you have a problem, you just go to the Discord and this helps solve your problems really quickly. So enormous community, and we have enormous participation, right? We have about 500 contributors that come and build Akash. So if you see a feature that you want to build, you can write a proposal yourself. So if you're an open source developer, if you like building open source, Akash is the platform for you because it not only lets you use an open source system, but also lets you build and pays you. Like if you have an idea that you think you can run on Akash, you have, I believe, $25 million in the community pool, then you can apply for a grant and use Akash. So a lot of university students are using Akash that way too. So it's not a company you're dealing with, it's a community you're going to be part of. So that's a big difference between using Akash and a company with products. It's not a corporation; it is a community, right? So if you are that type of person that believes that communities can actually like solve societal problems, Akash is for you. But if you are one of those people that want to pay a company that can leverage decentralized stack as well, there are options, and of course, like companies out there that are offering something similar to Akash out there that you can take advantage of.
Is there anything that I didn't cover that you'd want listeners to know?
No, I think just I think I want to emphasize why this model is going to be extremely important, and I think why people doing AI, especially training, should be considering some of these models. Like our biggest challenge for AI, there were two big challenges for AI training, right? The one was data, right? We didn't have data. There's a data limit as to how much you can get data to train. And second was energy. We solved the data problem. What you saw with what we saw with DeepSeek, it can use synthetic data. So it's very, very amazing using synthetic data and using mixture of experts mechanism. You can actually solve the data problem. But what we cannot solve is the energy problem. I think that's why it's very, very important if you're doing training to focus on distributing your training runs versus trying to go with the traditional mechanism of centralizing your training runs. And because we're going to hit a cap in 2 years and we have no solutions, right? That's why we have $500 billion supposed investments, and a lot of the investment is going towards power infrastructure. But by the time we realize the benefits of the investment is going to be late. So highly encourage folks to take decentralized or distributed training more seriously, and look into mechanisms employed by Noose Research. Noose is a top team. They came up with something called Distro recently. Google DeepMind came up with a paper called Dialoco. There's several companies that are having their own approaches, and some of them reduce the uh, one approach is like reducing the amount of communication between the nodes to train better. Some of them have better verification mechanisms employed locally to train better. And I love to see more work, more different approaches, and more experimentation in the space. And that's really, I think, going to benefit all of us. And really take the power away from the open AIs of the world. If you want to really disrupt them, you have to think about decentralization.
I'm past the point of looking for jobs, but I'm not past the point of looking for people to hire. And when I need to do that, I turn to Indeed. Imagine you just realized your business needed to hire someone yesterday. How can you find amazing candidates fast? Easy. Just use Indeed. When it comes to hiring, Indeed is all you need. You can stop struggling to get your job post seen on other job sites because Indeed's sponsored jobs help you stand out and hire fast. With sponsored jobs, your post jumps to the top of the page for your relevant candidates so you can reach the people you want faster. And it makes a huge difference. According to Indeed data, sponsored jobs posted directly on Indeed have 45% more applications than non-sponsored jobs. Plus, with Indeed sponsored jobs, there's no monthly subscriptions, no long-term contracts, and you pay only for results. How fast is Indeed? In the minute I've been talking to you, 23 hires were made on Indeed, according to Indeed data worldwide. There's no need to wait any longer. Speed up your hiring right now with Indeed. And listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed. To get your jobs more visibility, go to Indeed.com/IONAI. IONAI, as always, all run together, EYEONAI. That's Indeed.com/IONAI right now. And support our show by saying you heard about Indeed on this podcast. Indeed.com/IONAI for a $75 sponsored job credit.